All right, so now we're on page 2 of the study guide, and it says at the top, use a calculator. Please do. You're asked to find the geometric mean of the problems below. If your answer is not a whole number, round to 3 decimal places. So remember, anytime we find the geometric mean, we're going to multiply two numbers and take their square root. So for number 13, we get 5 times 100, and we're going to take the square root. So that becomes the square root of 500. And then in our calculator over here, the square root of 500. I get this long number. So I'm going to round to 3 decimal places. And if you look carefully, the 6 is going to tell me to round that 0 to a 1. So I'm looking for 22.361 approximately. All right. Now, you can kind of do these in one step in your calculator. So for the geometric mean of 7 and 13, if you have a graphing calculator, you can do the square root button, and just under that, write 7 times 13. Make sure that the square root symbol extends all the way over that expression, but you'll get it in one step. The only thing I'd be cautious of here is that if you do this in one step, I can't see your work. So if there is a mistake, it does help me to know that you knew that 7 times 13 was 91, and then that the square root of 91 is approximately 9.5, and then 39. Okay, so we'll try these. You know what, I think I'm gonna multiply these all out. So 20 times 30, we're gonna get the square root of 600 for the geometric mean. Take the square root, we get approximately 24.495. So be careful rounding. That 8 will round that over to a 5. Oops, marked on my calculator. 1 and 64. Well, we know 1 times 64 is 64. So the geometric mean of 1 and 64 is the number 8. So we got a whole number. All right, keep on keeping on. 17, 4 and 9. Some of these we can do in our head. I know 4 times 9 is 36. So the geometric mean of 4 and 9 is 6. Number 18, 8 and 10. I know 8 times 10 is 80. So to find that geometric mean, I know it's not a perfect square, but it's going to be close to 9. Oops. 8.944. So approximately 8.944. All right, geometric mean of 6 and 7. I know 6 times 7 is 42. So I'm going to multiply and find, sorry, there's some other people in the room with me, the square root of 42. So we'll get approximately 6.481. Be careful here. Make sure you round. That 7 tells us to turn that 0 to a 1. And then lastly, 3 and 8. I know 3 times 8 is 24. We could simplify that, but instead, since we're able to use decimals here, let's just stick with decimals. We get 4.899 because again, the 9 in the calculator will tell us to round that to a 9. Okay, if you go down to the next section, we're now looking at similar triangles in number 21. Remember that when you connect an altitude, this is your altitude, from the vertex of a right triangle to its hypotenuse pictured below, so EG is the hypotenuse, the triangles created are always similar. In the space provided, this space, sketch all 3 triangles so that they are oriented or facing the same way. Then complete, should have put a comma there, then complete the similarity statement below. And here's our similarity statement. So the first thing I want you to do is sketch these. And I like to label them small, medium, and large. It's like our little Goldilocks triangles. Whenever I do this, I always put the right angle in the bottom corner, and then I always kind of over-exaggerate the short and long leg so that I know when I go to use these values later, I know which is short and which is long. So if I look at my smallest triangle, my short leg, I'm gonna relabel this. So I know it's kind of backwards for the small one. So this was my H, this would be vertex E, this would be vertex F. So that the hypotenuse is FE, the short leg is EH. For my medium triangle, I'm kind of looking at it this way. So I'm gonna have H for the 90 degrees. HG is the long leg. So H is the vertex of the 90-degree angle. HG, we said, is the long leg. FH is the short leg. So this would be the vertex F. And then lastly, that large triangle, this one is drawn like it appears over here, FGE. So I'm going to copy that FGE. Now, you could have drawn these, with the right angle on the other side. I just want all of them to be facing the same way, where the right angle is in one of the same places. Okay, so now, if you look at the similarity statement we're given, EFG, and if you go to the picture, EFG is your large triangle. I might even write that under here. So I have to look at what order it was named in. EFG. I'm going to copy that order. FHG for the median. Oops, don't forget the triangle symbol. I almost forgot it. FHG. So if we look at these, EFG traces the short leg then the long leg. FHG does the same for the small triangle, EHF. So triangle EHF. I'm going to rewrite that above. That got a little smushed there. All right, so that was our medium and that was our small triangle. All right, they must be in this order. This is either correct or incorrect. We cannot reorder these over here. It must be FHG and EHF for these two triangles. You could, I suppose, put the small one here and the medium one there. All right, so now in questions 22 and 23, we're asked to do the same thing, except you don't have to do the sketch. So it says, name two triangles that are similar to J and K. So first of all, J and K is our medium triangle. What I might do is I might still sketch these. So here's my small, here's my medium, here's my large. And if I'm looking at this, J, N, K is this triangle, where N is the vertex of the 90-degree angle, J is the smallest angle, K is not as small as J. All right, so now if I look at this, this will be N, L, hold on, I already messed that up, sorry, that'll be L, and this will be K. So if I look at this triangle, I have N here, L over here, and K at the top. And then the big triangle, the right angle, has a vertex of K, from the short side, K to L, the long side, K to J. It takes just a moment to double check these. So it won't take too long just to double check maybe just one side. I'll check all the hypotenuses. So on my small triangle, LK is the hypotenuse. LK is right here. My medium triangle, JK is the hypotenuse, JK. And then on the large, JL is my hypotenuse, and I wrote JL there. All right, so now when I name two triangles similar to J and K, they're in this order, J and K. Start at the top, go down, go over. So I'm going to get triangle JKL and triangle KNL. All right, excellent. We got one more of those.